Okay, so welcome everyone. We are in week 12, session 1. So today we are gonna continue working on chapter 6. So as I mentioned, next week is gonna be the second SQL exam. So this week we are gonna finish the chapter 6. And then after the exam, chapter 7 and 8, and then we are done. Only comprehensive exam left for the last week of April, which is gonna be in exactly 4 weeks from now. So today we are gonna continue working on chapter 6. We are gonna go through some things that we had some touch on chapter 2 regarding the updating the tables, deleting, inserting, all the things that we need to know when we are dealing with the database. And then we are gonna learn a new feature today, which we call it as a view definition, which is really helpful. We will learn how to write the SQL syntax for the view definition and why these views are important for us. But as we know, creating a database is one thing. Maintaining a database is another thing. So in order to maintain a database, you need to know how to insert data to your database, how to delete data from your database, how to update your database. Sometimes you need to, for example, update some columns. Sometimes you need to change some attributes name. Sometimes you need to add some attributes to your column, to your table. So that's why we need to again go through the, hey guys, come on. So we need to go through these three syntax that we had on chapter 2, insert, update, and delete. But today we are gonna go through more details, more syntax, how we can, for example, create a copy of a table, how we can create a copy from some specific attributes from the table according to different condition with the where condition. So same as the previous session, we are gonna first see the syntax for them, and then after the syntax, we are gonna run those SQL codes in the advanced editor window. So make sure to have this one open on your side. Same as the previous session, we are gonna do coding. Any questions so far? No? Okay. So again, for inserting a function, we can add some records, we can add some rows, some data to the table. Sometimes we can just add one row at a time. Sometimes we can add multiple rows. We will learn how to do it. For updating, as I mentioned, for example, you want to add some, you want to change some thing in your table. For example, you have the list price column, list price attribute in data, and you would like to, for example, increase the price for 10%. So we'll see how we can do that. And for the delete one, we would like to, for example, remove some records, some data from some rows from the table. We will learn how to remove, for example, one individually, or for example, multiple rows according to the different conditions, which we put conditions in the where statements. So by inserting. So first, let's just start with the for example, you have a table and you would like to, for example, have a copy of some specific row, some specific attributes from some table and create a new table. So in this case, the function for it, the syntax for it is the create table, like the one we had before, and the table name, whatever table name that you would like to have, and then as select asterisk from the old table name, whatever table name, again has based on different condition if you have it. Okay, so we will learn how we can address the old table name. In our book, we have different type of database, Redcat1, Redcat2, Lorenzo, and also your credential. So for example, we will learn how we can copy from a Redcat1 database and create a copy in your credential, in your student database that you have. And then, for example, you can add records to your database. Again, sometimes one record at a time, sometimes multiple records, multiple rows. So in that case, for the first one, the syntax that we have exactly in the chapter 2, the insert into the table name, whatever table name that you have, and then whatever attributes you have, whatever field, whatever column, and what are the values exactly one by one. So value 1 goes to the the field 1, value 2 for the field 2, and the rest. Exactly like the one we had in chapter 2. But this one could be a little more new for you. So for example, this one goes adding multiple rows to the table, insert into whatever table name, select asterisk from the source table name. So whatever source table that you have, we will see, for example, product table in the Redcat one. I would like to just make a copy of some rows from that table and inserting to the table that I just created based on the create function. So let's go through these 3 examples together, and then after doing syntax for this code, you will have a better understanding of these new syntax that we have. So the first one, create a copy of the customer table name, customer copy. So while you are thinking on this one, I have to go to my office and bring my cup for water. But again, you already have the syntax for it. So exactly, you need to use the first one. Okay, the only things that you need to know at this point is to, for example, mention you would like to use the customer copy, customer table. You would like to make a copy of this one. In order to address this one from the Redcat, you just need to put Redcat dot customer. So technically, it goes to find the customer copy from the Redcat database. Okay, you can put Redcat 1, Redcat 2, but if you just put the Redcat is enough. So technically, with this syntax, create table, new table name. What is the new table name? For example, customer copy. As select asterisk from, what is the old table? Redcat dot customer, where we don't have condition at this point. So make sure to do it. I'm just gonna come back very quick. So did you do it on your side? So as we know, simple. So we can have it. Let me just create a copy. So the main point is, first I added the first line. drop table if exists customer copy. Since I already created this table, I need this one. But for you, since you are just doing right now, you are not gonna get any error if you just run these 3 lines. So the syntax that we had, create table, customer copy, the name of the new table as select asterisk from the redcat.customer, okay? And you can just ignore this as, and you can also have this as, but I always recommend you to put this as here. It's better to have it, not just for now, when you're using the aliases, it's always better. It's more like a good style to just get the habit of using this as here. So if I just run the syntax, first of all, the table, if it exists, is going to be deleted. And then we can see that right now we have 4,417 record affected. So we are just created a new table, name it as a customer copy. And just one syntax, just not in your book. If you want to see which tables are in your database, so just by having this syntax, show tables, so you can see all the tables in your database. Okay. So for example, for me, it's definitely more than you because I already created those tables. But if you just do it, you can see which table are already available in your student credential database. Okay. So let's go to the second example. Add yourself as a customer number 20,000 into the customer copy table. Okay. So we just create the customer copy. What was the syntax for it? Insert into the table name, which is the customer copy. What is the value? Whatever. So technically, since you don't have, you have it, but we don't want to spend that time to just find which attributes you have. So this is going to be the syntax for it. So let me. So where did I get this attributes name? How could I get these? Diagram, or if I don't have a diagram, I can just easily mention that select asterisk from the customer copy. Then I can find whatever attributes I have in order to not make a mistake. But insert into the customer copy, these are all the attributes we have, and then the values, whatever name you have, your address if you would like to put that, and then just the ID, customer ID is 20,000. Right now, I just inserted this data, this table, and then in order to check, I can check it here. Select distinct asterisks from the customer copy table where customer ID is 20,000. So right now we can see this one just inserted to the database. Any questions so far? No, the only thing that was so far new for us is to how to address a table from other databases in your database management systems that you have. Yes.
So, the attributes that we have, the street address is included in there. But since you didn't put street address up there, for you.
Yeah, because I didn't have it here. So technically it's a null value, but it doesn't show me anything. So I have the, I don't have the also the, what is it? The street address up there. So technically it doesn't, it exactly go one by one. So the customer ID, do we have customer ID here? It goes to the customer ID. What is the exactly one by one value is 20,000. Even the order doesn't matter, but after, okay? Just exactly go to the names and find a match here. And since we don't have a street address over there, so technically there is no street address here we addressed.
So if you just like deleted all of those.
Yeah, just for example, mention customer ID first and last name, Let's do it together. Customer ID, first and last name, name it 21,000 and just these four. Now also this one. So let's run the query. It just showed me the Nick Ball 20,000. So again, that's the type of critical thinking question. You think, you see, okay, what would happen if I change this to this, and then that's the time that you will learn. So let me go to the next one. Okay, create a sale item archive table. Copy all sale items with the sale price greater than $150 into the archive. So first of all, the syntax for it, we have it here. So you can, for example, insert into the whatever table that you just have, the one that we have, selecting from the source table name we have. Okay, so let me okay. But the point is here, we have to first create the sale item table, okay? So again, you don't have access, I mean, right now you don't know what are the attributes for it. So first, you always start with the drop table if exists, okay? And then we go with the create table function. What is the table function, table name? This time is the sales time archive from which database? Redcat database, and the table name originally is, what is it? The sale item, and then let's see the syntax together. It's gonna make sense for you when you see it. Let's run it. Okay, let's read the table together, the syntax together. Drop table if exists, sales item archive. For you, you don't already have it, so it's gonna be okay. And then create the table. What is the table name? Sale item archive. These are the names of the new table that I would like to have. Okay, sale ID, integer, primary key. Product ID, integer, item size, decimal. What does it mean by 3.1? So what's gonna be the output? Give me the example of output of this one. Okay, so give me the number. Then, for example, 12 and a half. Mm-hmm. Mm-hmm. 8.5, for example. 3 characters, 3 integer, and also 1 decimal, because this dot also count as a one of them. Okay, so the quantity integer, and also the sale price, again 10 characters with 2 decimal points. Now it's time for us. We just created the table, sale item archive. Okay, now we have to insert into this table from select asterisk from the redcat.sale item where the sale price is 150. So technically, you just create the table and then you inserted multiple rows from your current table with some specific condition. What is the condition? Sale price is greater than 150. So instead of inserting one rows by one row, so technically we just inserted from this current table with the new condition that we have. So run query, we just created the table. So if I, for example, what is the table name? Sale item archive. So can just check it right now. The new table that we just created is the sale item archive. These are the attributes, and we can see all the sale price is over 150. Okay. Any question for the syntax? Is the syntax logic clear for you? So these are the three versions of the question for the inserting. First, creating a copy of the table, inserting some, for example, one rows of the data to the table, and also create a table and copying some rows based on some condition from your current table into the new table with the third example. Yes.
So say that the red cat table and still item had more attributes. Still item archive that we described that we created. Would it pop up an error? It was trying to insert data that we did not have.
You mean from the original table?
Yeah, that one had attributes. Would it give us an error or would it just create?
No. It doesn't give it. It's exactly again go through. For example, the original table you mean has, for example, 12 attributes, but the one that you just created has 6 attributes. So you are not gonna get error.
Or just give us a
Yeah. It goes through the again those that has the same attributes name and match and copy. Okay, so the second type, updating the table. You already have the data, it's already in the system. You would like to, for example, add uh, some update to the table. I don't know, updating the list price, updating the, for example, some specific estate's name, whatever. Okay, but there is only one thing that you need to pay attention when you're updating your database. If you don't mention any condition, whole table is going to be updated. Okay, but for example, if you, for example, mention, I would like to update this sale price greater than $150, then you are going to just update some specific part of your database. So that's important. You need to pay attention. If you don't have any where condition, technically you're updating your whole table. Sometimes it's okay, sometimes it's not okay. You need to see the example, in at least in our case, what the question asks from you. In the real world, you need to see what's the scenario that you're working in. So the syntax is easy. Let's start with the update, the table name, whatever table name, then you need to have the set statement and the field name, the attributes name that you would like to have for whatever new values that you would like to replace or change based on the different condition. So let's see these two examples. The first one, update all customers from the state of Washington, state with the all capital letter, and we would like to change it to this version, W and the lower A. And then the second one, create a copy of the product table, name product copy, update the list price for all product to reflect 5% increase. So again, we mentioned you need to always start with the update and the table name. The table name here is should be just the customer copy. Customer copy. and then the set. Okay, that's the attribute, that's the syntax that we need to have. And then the state equal to WA, where exactly the state is capital. So let's also run it. So again, updating whatever table you have, which is customer copy, the syntax is set, where the state is all a WA in this version, where state is WA. So if I run it, so 92 records affected. So we can just also easily check by the select asterisk from the customer copy to see if what's happening here. Okay. Let me see if you're still sharing. Okay, good. So we can see right now all the states change to the capital W and lower A. Create a copy of the product table, name it as a product copy, update the list price for the all products, reflect the 5% increase. Okay, so we know how to create a copy of the table already. So first, I always start with the drop table. If exists, table name is product copy, and then create the table. What's the name? Product copy as select asterisk from redcat dot product. Okay, so far I just created the copy. Okay, and then updating table name product copy, set the list price. Is the attribute name is list price? Yes. List price equal to list price times 1.05. Clear? So again, first drop table if exists product copy, create table product copy as select asterisk from the Red Cat database, which table, product table, just created the copy of the table, update the product copy, set, and as the syntax that we need to have, list price equals list price times 1.05. So technically, we just updated the list price version to 1.05% to 5%. Any question? No? Mm. So the third one, the delete version. So again, sometimes you need to delete some attributes, some rows from your database. Okay, in that case, it's a start with the delete statement from which table that you have, whatever table name you have, where some condition. Again, this one look like to the update statement. If you don't have a specific condition for it, it's gonna delete all the rows from your data. But for example, if you say, okay, just delete those items that the list price is over 150, so it's just gonna delete those rows that have the price of the over $150. If you don't mention that condition, it's gonna delete all of them. So again, same as the previous one, you need to pay attention to the where condition. And for the delete, same as the update, if you delete it, for the update, still you can just update to previous version. But if you delete it, it's gonna gone forever. So always, technically it's must. You need to first always create a copy of whatever table you would like to work, and then work on that copy version. If everything is okay, you can just reply it. You can just apply it to the original table that you have. So let's see the example. Delete all customers in the customer copy table that we just created from the states in these four corners: Utah, Colorado, Arizona, and the New Mexico. So technically, you can use the in statements in your database, in your syntax, to address these four states. So exactly just like a simple English that we just read, we start with the delete from which table? What's the table name? Customer copy where the state in, what is it? Utah, Colorado, and the rest. Arizona and New Mexico. So delete from customer copy where the states are these. So technically, by running this in the customer copy table, 206 rows of data just got deleted. So if I don't put this where condition here, technically we are creating all the records from the customer copy table. And again, like all previous weeks that we talked, just by watching these, you're not gonna learn. You have to go back and go through the books, run all those boxes, SQL boxes, run it, try to challenge yourself, try to see different scenario, and then do the assignments, and then at that point, you just maybe learn something. Good. Delete all products from product copy table with the list price below $10. So just delete from the product copy where list price less than simple. Good. So these are all the three categories that we need to know: inserting, updating, and deleting. So that's the way you can just maintain, update whatever database that you have. So this is all the three things that you need to know about the exactly inserting, updating, and deleting data from your current database. Now, let's talk about the views. So what does it mean by views? Why they are useful? So any idea what is views in a database? No? Do you have any guess?
So window.
So window, but for a purpose. The format what you explained. Could be. I'm a database administrator. I have access to, for example, a table of the employee. And the table of employee, there are some attribute, first name, last name, address, whatever, social security number, all the things. And this table, it should be available also for other, for example, employee. But I don't want them to see the SSN. I don't want them to see personal information, important information for the other employees. In that case, I will create not a table, real table. I will create a virtual table. The virtual table, all of them are virtual, but we just get what I mean. So by virtual, which means the table that technically it's representing the table that you have already, but with more limited feature. And then the point is you cannot update that virtual table. You cannot insert anything into it. You cannot delete anything from that. You have to update the original one, and then it will automatically update the view version. We call this virtual table as a view. That's it. That's the only thing that we have to know for the table. So technically, then you are not copying a database table. We are just creating a table which is just representing the original table. That's it. Sometimes with the less attributes, but the main point is if you want to update that table, you have to update the base table. Exactly, we call it base table. That base table, if I delete something, if I add something, it's gonna shows in the view version. Okay. The syntax for it is easy. Create view instead of create table. Instead of table name, we call it view name. For example, I don't know, product view table. Again, as select whatever statement that we have. Okay, so we will see the example. And then according to the view that we are gonna create, we can also ask some queries from that view table. You can treat it with exactly like the normal table, except you cannot delete or you cannot inserting data to it. You can ask queries from it. For example, I would like to see those employees that got hired, for example, after 2010 in our organization. I can ask those syntax from the view table of the employee instead of the table, the base table of the employee. Okay, so in your book, uh, if you go to chapter 6.8, view definition, there is a syntax here. Select asterisks from information under an schema.tables. Okay, this syntax shows you all the tables that you have in your database, all the databases. But the point is, it's gonna show you the table schema and also the table name. So here we can see here the table type. Some of them named as a system view. If I scroll down, we can see some of them are base table. Okay, these base table are original table that we have in our database, like the product table from the Red Hat database. If they are view, it's gonna show us as a system view or view. Okay, so this is the one way that you can check whatever tables that you have in your database. But let's go to the create a view of the customer table that includes only the first name, last name, city, and the state. So technically, the customer table has multiple attributes. Okay, I would like to just have a table that show me the first name, last name, city, and a state field, and I don't want to create the new table. Okay, it's gonna be a mess if I create a new table and then, for example, I forgot to update some, and then it's gonna be a real mess for the future. But if I create this view, I'm not gonna worry about this view anymore. If I update the original base table called customer, all the things is gonna reflect in the view table. Okay, so the syntax, we have it. First, we also have the drop view if exists. So we had the drop table if exists. Exactly, we have drop view if exists. I want to check if that table is if that view is exists, so I can just do drop. Then create view instead of create table. I just name it customer view as select first name, last name, city, state from which table, which base table, customer table in the Red Hat database. Okay, so we can see that we created that one. So if I have select asterisk from customer view, so you can see right now, it's exactly we are dealing with a table. But just this table, again, it's a virtual table. We cannot add anything to this table. We can ask whatever query we want. We can ask, for example, just give me the list of the customers that state is, for example, Alabama and I don't know, New Mexico. I can ask all the question I want. I cannot delete it. I can delete any rows from it. I cannot adding anything to it. I cannot updating this one. Okay. I can remove the customer view again for a data administrator role. So they might, for example, restrict some users from even deleting some tables, which it should be. Otherwise, all the customers, all the employees, they can delete whatever table in the database. So the result, we will talk about it on chapter 7 and 8. People, they have different authorization in the organization for the database management. But again, that's how view works. So now the question is it clear what is view for you? Yes? So nothing new, just a different concept, different view. Let's have the new. Try to write it on your side. Create a view of the employee table that include the first name, last name of the employees as well as their hire date. So technically, Nothing new. We are just creating a new view. What is the view name? Employee view. Let's name it employee view. Selecting first name, last name, hire date from which table? Employer table from the Redcat database. Employee table, sorry. Again, drop view if exist. Create view. I just name it employee view as select first name, last name. Don't know what's happening. First name, last name, and also the hire date from the redcat.employee. Okay. And the main point of this view, everything that we already learned, whatever we already learned so far, it's exactly again applicable to this. For example, you might want to create a view of a table that you need to deal with joining different tables together to have some output. Okay. So whenever we run the join function, technically we are creating a new table, right? With the new table, we are just having, I mean, the query that we just ran, we creating some table with some specific attributes. I don't know, customers that, I don't know, purchased item over $10,000 in some states with some specific product. So you can just also create the view of that one. So technically, if we change the original table, your output, which is the view, is gonna also change the same thing. And those view is gonna exist, is gonna permanently available in your database unless you delete them. So now let's create this one. Create the view of the customer table named customer view that includes only the first and last name city states field where customers in Utah. I go to the assignments. Again, drop view if exist customer view, create view customer view, select first name, last name, city, states from which table, customer in the Redcat database, where the state is Utah. So technically, the new table just create, the new view just created. Again, this customer view is going to be permanently in your database. You can, whenever you want, you can call it, you can ask query from it. You cannot insert anything into it. You cannot deleting anything from it. You cannot updating it. If you want to update this view, you need to update the original, the base table, which is in this case, customer table in the Redcat database. Good? Any question? Mm-hmm. Oh, this table, just exactly look at it as a table, as the original table. Instead of, for example, select asterisk from the product, this time select asterisk from the customer view, product view, whatever name that you just create. It is exactly look like the table. So you can just, this time, this one is, having issue with the HDMI cable. So just again, that's a good question. Just pay attention. The view, as I mentioned, you can just deal with it exactly like the original table that you have. You can ask queries. You can ask different type of join questions. It's exactly look at the table. The only thing is different. You cannot update it. You cannot adding anything to it. Okay, that one is exactly representing of the original table that we have. Okay. So let's go to the assignments. So let's go to the 6.7 section. And we have multiple questions according to the creating a table, dropping, removing, updating, deleting, inserting syntax that we have. So first of all, the original database that we have, again, we have it here, but this one, it's asking us to create a new table. Again, all of this is going to be recorded. You can just watch it later. Just pay attention now. Create a new table, name it as a purchase 61. We have it, the new table name. And then insert into the purchase, into it, the purchase records of the employee 61 that were made after Christmas in 2014. Between this date that mentioned, use between, and also use the date format, year, month, date. Okay, so we have to create a table, the syntax for it. We have it, create table. What is the table name? The new table name, purchase 61. And then as select, what are the original one? The original one is from the Redcat database. The name is the payroll purchase name, where employee ID is 61, and the purchase date is between these 2 days. Okay, so December 26th to December 31st. So if I run this one, I don't remember if I'm gonna get error or not. I think I'm not gonna get error because I deleted the original table. Okay, if you run it for your first time, you will not get error for sure, but I will just make sure to drop table if exists. Okay, so now the new table just have 7 records, and we can just see if I delete this one and run it, am I gonna get error? Why? Yes, I already have this table. Okay, So you can just put it back and run it as many as I want. Okay. The Let's go to the third one. Let's do the second one as well. Why not? Do it on your site. So this time is mentioned, create a new table, name it purchase item 61, purchase item 61. And then from which table purchase item, where the purchase ID here, as we have, technically we are mentioning in the inner statement because we may say, okay, there will be multiple output for it. So if I run it, I'm not gonna get error, I think, because I have it. So just we can also just simply mention drop table if exists, purchase item 61, and then okay, good. So in the previous problem, you created two new tables, purchase 61, purchase item 61, okay, in your credential database. So now you need to delete from purchase item 61 the records for the manufacturer whose ID is 630. Again, we are deleting some. If we don't mention any condition for it, we are going to delete the whole table. So in that case, simple. So we can just let's do it together. So we are going to delete from which table? Purchase item 61. And what's the condition for it? Manufacturer ID is 630. Run it on your side. So we can mention delete from the purchase item 61, Verge purchase ID. It could be from the purchase ID from the purchase 61 table, where the manufacturer ID is 630. Okay. So let me just run it. And then the other one, we are deleting the purchase 61. Okay, so this one is also, we can just simply run it, read from purchaser where the manufacturer ID is 630. I would like to go to the second. So let's also see this one. Again, simple. We need to update the table. Okay, we need to increase the shipping cost of every purchase from the manufacturer in Massachusetts by 10%. Round your calculation to two decimal points. So updating which table? Purchase 61. We need the set function, set a statement for it. Set shipping should be equal to round shipping 10% by 2 decimal points. First of all, we are using a function for it. And then where the manufacturer ID, it's gonna be in these groups. The manufacturer ID from the manufacturer table where the state is Washington. Okay? Yes. And I'm just gonna show you. Make sure to definitely work on your side again as assignment. So let me go to the third one, the second assignment. The 6.7, it just have 3 questions. This is the table asking you writing a table. Again, all of this is going to be recorded, available for you later. At this point, just pay attention to the questions. You can just go back and watch all of this. So create a view of all data in the manufacturer table, but only include data from manufacturer in Ohio, all is state that we mentioned. Simple. Drop view if exists instead of drop table if exists. Create view. What is the table? What is the attributes? The view name. It says Midwest manufacturer. Select asterisk from the manufacturer table from the Redcat database where state is these states that we have. Okay. And then this one, create a view of the customer from New York who have purchased more than $200 of the product, not including tax and shipping. Name your view as this one. So technically, again, dropping, creating a view. The view is FAV New York customers as select from the Redcat customer, where we need to have the subquery here, where the number of items, the amount purchased is over $200. So where something is greater than 200. So I have to, like the one that we mentioned in the last session, for the, what is it? The subquery. We are creating food for the higher queries. The food here is the purchase amount. And just calculate the purchase amount with these syntax, which is the running the join function that we have. Okay, this is the assignments. So just go there and try to figure out yourself. They are here. You can just go there, watch it, pause it, copy, paste. I don't want you to do that. Just go ahead and do it on yourself, think it. As I mentioned always, I don't care about your grade. The only reason I care is you just to learn, okay? And this one, you need to have 2 technically subqueries inside each other, okay? Again, answer are here. But first, please go there, try to run it by yourself. If you would like to see, you can just come back and watch and pause and just copy and paste. I don't care, but you will definitely not learn in that case. So here, create a view of manufacturer with more than 10 products. First of all, 10 products. We use the count function. So we would like to find those that have over 10 products of item. And the list price of $20 also. So technically, we have to use multiple queries inside each other to calculate some food for the higher queries, which is over 10. And also we have some condition here, list price over $20. So that's how you can also create this view. So just the only thing that I'd like you to just learn from this session, especially for the view one, it doesn't matter it's a view, it's a create table, it doesn't matter. The only things that matters, all the things that you need to use in those statements, you already learned all of them. Join functions, subqueries, left join, right join, whatever things that we already learned. So we can use those in creating the new views, creating the new table. So it doesn't matter. Do you have questions? Okay. So that's the points regarding the view. So let me stop the Zoom. The recording. So welcome everyone. We are in week 12, session 2. So today we are finalizing the chapter 6. And then next week, as you know, next Wednesday is your second SQL exam. What we are gonna do today is going through the last assignments of chapter 6, which is assignment 6.8. And then before that, we are gonna just go through almost 10 examples from the Redcat 2 database. So technically today it's all hands-on assignment. So definitely make sure to do the coding, and then let's start. So for the last time in this chapter, in this class, you're gonna see this screen. So again, as I always mention, the order of syntax that we should write is matters. That does matter for us. So select from, we have to always start with a select, as you definitely know already. Then we are going to the from, which which table, which relation, which object we are gonna extracting some data. And then if you have any condition, we are gonna use where condition. And then according to the different situation, we have to use the group by. So do you remember when we need to use the group by in our syntaxes? Yes, when we have the aggregate function, and when we want to also do the categorization in our result, we need to use the group by. When you use the aggregate function in the select statement, if we have it that one alone, there is no need to use the group by function. But if you have other attributes, you should definitely use the group by for those attributes. And then if you have also extra condition according to those groups, you need to use the having, and then finally order by which is done. But we know that the order of execution always with the start, we start with from, then where group by having select, and then at the end we go to the select statement. So this slide is not available in the D12. You don't have it. So now we are just gonna go through it, and you need to just make sure to have the your advanced query, make it open for yourself, and then database MySQL credential Redcat. So if you are done, do the coding on this one. So let us start with this example, with this table that we have, the one that we already have, the Redcat 2. So customer, product, manufacturer, sale item, all the tables that we have. So let's first start with the first example. But before starting, let me also pull up the table here for you. We know that in the introduction page, there is a table for us as well. So let us start. List all customers who made purchases over $500 in total. So I will wait for you to do the coding on your side, and then we'll start working on it. So just from the table, we can see that we are going to work on the customers who made purchase over $500. So from the table, we will understand that we have to work with the customer table, sale table, and sale item table, because at the end of the day, the sale price is available in the sale item table. So technically, we have to connect these tables together, and we have just one condition. What is the condition? Purchases over $500 in total. So as you see, it says the purchases over $500, which means the number of items times the price for each item. You have to calculate it, okay? Because, for example, you purchased 2 items, each item has different price, so you have to times those and make the summation of those items. So technically, we need some function in the selected statement, sale item price times the quantity that we have. So we have it in the sale item table, the quantity sale price. So technically, we have to use this one and then list all customers. So which means we need to use the first name, last name of those people. And we have the aggregate function. So technically, we need the group by as well. So we can say, as you agree, we have to select the statement. So we need two customers information. So first name, last name, whatever we need. The things that matter for us is this aggregate function, the summation of the sales price times quantity for each customer. So technically, we have the aggregate function, we have the two other attributes. So for sure, we need the group by as well. But from customer table, we will join the sale table, and then we will also join the sale item table, and then group by, and that at the time we have to use the having the total purchase over $500. So in that case, we can run it this way. Hello. So we just started the first example. Today we are just going to go through the different example for the next week exam. So we have the customer ID, first name, last name from the customer table. And as you see, I use alias for all of them. This is the version that you should practice for your coding later. Always use the alias, always worth it, yes. Chapter 6, yeah. So this is not in the book because we already finished the chapter 6. We are just doing the practice for the next week exam, yeah. So, and also the PowerPoint is not also in the D2L as I mentioned. So this is all the practice and all the examples we are doing right now. So from the customer table, which we have, we are going to join the sale table. What is the path? The path is customer ID. And then from the sale table, we will join the sale item table. What is the path? Sale ID again in this table. And then we have the aggregate function in the selector statement. Yes, we have a rule. If we have other attributes beside those aggregate function, we have to use the group by for those. So group by based on the customer ID, first name, last name. Having total spend is over $500. What is total spend? Summation of the sales price times quantity as the total spend. Okay, so in that case, when we run it, we will have the total spend for each customer, which they are over $500. Any question for the first example? Is the code logic clear? Yes? No? Yes. Mm-hmm. Mm-hmm. Yeah, for example, I am a customer. One time I purchased, let's say, 2 items with the price of $500. And then the next time I purchased 3 items, each items, for example, worth $400. Okay, so 2 times 1,000, 3 times 1,200. So that summation is gonna add these two together. So technically 2,200 is the whole amount of purchase I purchased from this company. Okay, okay. So because in the example we mentioned that the customers who purchased over $500. Good. List the products with their available stock showing product ID, product name, and total quantity on hand. Okay, so technically, again, as we always mention, read the text. List the product, which means we have to deal with the product table, right? And then we have to deal with the number of quantity in hand, available stock. So we need to make sure to check the inventory table, okay? So if we go to the table we have, so we have the product table, we have the inventory item table as well. So we have to deal with these two tables. And the common path between these two tables are product ID. So it's just very simple join function that we need to use. But the point is, we have to use the total quantity on hand for each items, each product. When we are saying the total, which means we are dealing with some function. What is the function? Sum function. Let me go back to the question again. The product with the available stock showing product ID, product name, and total quantity on hand. So we start with the select. So the attributes that we need, the product ID, product name, and total quantity. For the total quantity, we have to use the summation of the quantity, and then we have to go from the product table, joining on which table? Inventory table. On what is the path? product ID, and then we have other attributes next to the aggregate function, which means we have to use the group by, and that's it. So even if you could just write the first 2 lines, 3 lines of the code, do it. So I just want you to just practice as much as possible in class. Hello, hello. We just started, we are in the second example. Today we are just gonna do the multiple hands-on practice. So, as I mentioned, we need to have the product ID, product name in the selected statement, and then the quantity on hand that we need to have. We need to have the summation of those for each product. And then we are going to join the inventory item table from the product table. What is the path? Product ID. Simple rule. We have the aggregate function, but we have other attributes. So we need to use the group by as well. So these examples, they are not in the D2L. I'm not going to put them in the D2L. So just some example that we are going to have in class. This is the first example. The second example. With the product with the available stock. And they are based on the Redcat 2 database. Any questions so far? No? So the total stock is also here. Okay. Let's list all customers from New York who have not made any purchases. All customers from New York that who have not made any purchases. So first of all customer, we need to deal with customer table. Also, we are talking about the purchasing stuff, so which means we have to deal with the sale table as well. So these are the table that we need to deal, customer and sale table. What is the common path between these two? Is customer I. Okay, so we have to join these two tables. But there is something special for this question. What is it? The customers that have not made any purchases. So what topic we are referring to right now for this one? We have to deal with null values, but before null value, how we should join these tables together? Left join, yes. So we had these two before, table A and B, for example, and this is the X, Y, Z. When we just do regular join, we always extract this comment as output, okay? But when we are using the left join, we are dealing with the X part and Y part as a result, okay? So for the customers that purchased, they're gonna be in the Y area. But for the customers that purchase and also have not purchased, is gonna be the X area. So technically X and Y, what we discussed last week in class. So in this case, simple join, the only thing is that we need to pay attention is using the left join. Okay, so we are gonna run it. Customer ID, first name, last name. From the customer table, we are joining to the sale table, but left join. What is the common path, common key? customer ID, where the sale ID is null. We just want to see the sale ID that is null. And the state is New York. So these are the customers that have not purchased. So this is the list of the all customers that they purchased from the New York City. But with this condition, we are just dealing with only customers that they have not purchased. So if we have s dot sale date, we will see the sale date for these people are empty, but in this case, we will have sale date for some customers and those that are not. So did you see the difference? This is the regular one. I said, okay, left join. In this case, we are going to have customers that purchased and also customers that have not purchased. That's why we can see, for example, Kendrick purchased in this date, but David has not purchased anything yet. Okay. But with this condition, sale ID is null. In that case, we will have just the customer that have not purchased anything. Okay. So far, nothing new. Again, we are not going to have anything new today. We are just doing the review for the what we have learned in class in the last 3 weeks. Yes.
The left join. Is it because
No, when we said left join, so technically the left table is sale. Sorry, the left table is customer, the right table is the sale. Yeah. So technically A is the customer, B is the sale table. No, that one doesn't matter. And as you see, we have the customer ID here, but again, A equal B or B equal A, it doesn't matter. That one doesn't matter. The only thing that matters here, when we say the left, the table that we state first, that one is gonna consider as left. Any question? All good? Let's go to the next example. Yes.
use this because you want
Yes. No. The sale ID we should mention is null. I think equal to null also work. Yeah. I think so. I will check. We can check together. Sure. No, we are not. You mean this one? So in that case, it's gonna also shows those all the customer in New York purchase and not purchase. I think this one doesn't work. It should be is null. Show the top manufacturers by the number of products they produce. Number of products. When we say number of products, we have to count the product. So we just understood we need to use the count function in the select statement. And then top manufacturer, which means we need to deal with the manufacturer table. and also the products, which means we need to deal with the product table as well. So manufacturer table, product table, what is the common key? Manufacturer ID. Okay, so this one is also almost simple one that we had. The only things that you need to pay attention using the count function in order to count the number of product for each manufacturer. And since we have again another attribute, in that case, we need to use the group by function as well. Okay. So again, so selecting whatever we have, the only thing that matters for us is counting the number of products. Okay. So which means the product ID. And then from which table we are going from the manufacturer table, joining the product table. The common path is manufacturer ID, and then the group by based on the whatever attributes we have here. And that's it. And since it mentions show the top manufacturer, we have to order it in a descending order. Okay. So selecting manufacturer ID, manufacturer name, and also counting the product ID. We name it as a product count from manufacturer table, joining product table. What is the key? Manufacturer ID, group by whatever attributes we have next to the aggregate function, which is manufacturer ID, manufacturer name, order by product count in a descending order. So in that case, manufacturer ID 691, which is the Fashion Lab, the total number of product is 309. Okay, and just maybe this is the only new things that you may learn today. Just by adding limits, for example, 5, what's going to happen? Top 5. You can just see the top 5 as well here. Any question? All good? Display each product's average sale price if it has been sold. Group by category and sorted by category. So again, display each product's average sale price if it has been sold. So we are dealing the product table and sale item table, because the sale price available in the sale item table that we can see here, the product and also the sale item table. And then the common key between these two are product ID, we can see here. And then the only things that you need to calculate is the average of the sale price. The average of the sale price is the aggregate function, so we need to use the group by as well. So selecting the category from product table, product ID from the product table, product name from product table, and then calculate this average of the sale price from the sale item table and name it as the average sale price. Then we are going to join it from product table to sale item table. What is the common path? The product ID. And then we have the product ID, product name, and category next to the aggregate function, which means we have to run the group by for them as well. And then at the end, order by product category, just in order to have better results. So in that case, I'm gonna have the product ID 2, for example. The product name is this one, and the average sale price for this item is 22 something dollars.
Do we
Yes.
need a word? Or it has a sell price.
Please display each product's average sale price if it has been sold. Since we have already the price for those, which means they have already been sold. Yeah. This is the next one, similar to what we had last week. List all orders made by customers in the four corner states. So we are just gonna reviewing the in function. So again, list all orders made by customer, which means we need to deal with the customer table and also the sale table. Okay. And then we know that the estates for those customers mentioned here in the customer table. So technically these two tables through the customer ID where the so we are showing the sale ID from the sale table, customer ID, first name, last name, and sale date. Those three from the customer table, sale date from the sale table. And we are going from the sale, joining to the customer table. What is the key? Customer ID, where state in this list: Utah, Colorado, Arizona, New Mexico. Let me know if you have questions.
we do the same as we
Yeah, absolutely. In and if we didn't have in, we had to go and say, okay, CS state equal to Utah and CS state equal to Colorado and CS state equal to Arizona and CS state equal to New Mexico. It's crazy. Just by this line, you can just make the code more efficient. The next question is an easy one, but we're making it harder by just using the subquery. So list product that have a list price higher than the average list price in their category. We're not talking about the general. We're talking about the each product in their category. For example, we have multiple category, boots, I don't know, sneakers, whatever. So in their category, which product has the higher value in comparison with the average of that category? Okay. So in the normal world, we just use the average from the function. I mean, in the select and do this, but we would like to have it in a subquery. So in the subquery version, it is good idea to create a table that technically has the category and the average price for each category. So technically what I'm saying is joining from the table we have to the new table that we are creating right now. The new table, we have just two columns. The first column is the category. The second column is the average price for the category. And then we can just join these two tables with the category function, category attribute. So by selecting whatever from the product table that we have, joining on new query. This query, the subquery, the main reason for subquery is to providing food for the higher query. Okay, so in this case, I am joining product table through the category attribute with the new table, which that table should have a category and average price for the category. In that case, I can compare each product which the average price in their own category. Okay, it's gonna be something easy like this. So someone read the code for me, line by line. Yes. So we are just selecting these attributes, all from product table. Then from the product table, we are joining a new table, the table that we are creating through the subquery. Okay? So in that case, I would say the new table, what I want to have in the new table is the category column and the average of the list price. Okay? Now, forget everything, just pay attention to this query. We have the aggregate function, we have another attributes. So we have to use the group by for this one as well. So from product table again, we are grouping by category. Okay, so the new table has only 2 columns. Am I right? The first column is the category, the second column is average category price, which is technically the average of the list price. So right now, what is the common key between the product table and the new table, which we name the new table as the average category? Category is the common key. So technically, we are joining this table from product, joining to this new table on category from product table, category from AVG category table that we just created. Okay, where the list price from product table greater than the average category price from the average category table. So technically, the price of each product greater than the average of that specific category that they are in that group, or they buy product list price. That the last line is just in order to just make it order. So right now, if I also copy this one and put here, so we will see the list price that they are greater than the average of the exact category they are in. Cool. Please.
Get the average category price, obviously by the average one, then group by. So
Mhm.
you get that group by maybe manufacturers, group it by.
So the only way that we can use a group by is based on those attributes that mention the select statement. We just have category, so we should only have the category based on the grouping, but based on the category. Yeah.
So we had done maybe like one of the manufacturers.
Yeah, exactly. Exactly. If you remember, the main reason that we need to use the group by is just because of the difference that may happen in the output. If we didn't have the group by category, we will have some column, for example, let's say 10, 12 column for the average list price, but we would have more than 10 column, for example, for the category. I'm not sure exactly the number, I'm just comparing. So technically in the output, we are gonna have something like this, which they are not matched. The number of rows for each category should be matched in terms of being in the output. Yeah. So the other version that we can use is through the normal version that we know. So product ID, product name, category, list price, and name the list price in the evolve, in the select, and then we are joining from product table to product table again. Okay, P and P2. Through which attributes? Category attributes. Group by, product ID, product name, category, list price, which we have it here. Having the new condition for that group, the list price greater than the average of the list price in the second table. Order by this one. So technically, we can see here 1379,857. If I run it, 1379,857. So the same result, different coding. But the point is, we wanted to use the subquery.
Why do we have
because the where is exactly for some condition we need to mention before the group by. So here in this case, the condition that we are applying is for the aggregate function. So in that case, we have to address it after group by. Yes. So you just said from product. Let's think about it, because when I was doing it, I just told to myself we have to connect with itself. So in that case, you would say, let's run it. Maybe it is correct. So in that case, from product table, I think it is not possible. Then in that case, all of them is going to be from product table, right? This is the version that you're saying. Before running it, do you think, I also have to think about it. Do you think it's going to work? So let's see the results. No, it doesn't work. The reason is you're dealing with one attribute in one table. Once you're dealing with some rows from that table, that attribute, and also doing the aggregate function on that one. I think that's the only, when I was writing the code, this one came to my mind. I had this assumption that we have to use the recursive relationship with itself in order to do that. But, for sure, the error is just, the only reason that we are gonna have error is the average function. That's the only reason that we can have error. We technically we don't have error. The syntax works, but the point is there is no output for this syntax, which means the syntax logically correct. There is no wrong with the syntax. Average product. Okay. So if we remove this syntax, I think we should have output. Okay. So you see the average list price is exactly equal to the each list price because there is no grouping here. It goes line by line and check, okay, 180, it's the only line, have 180 and do the average. Technically, the average is equal to that. But when we are dealing with the average from the second table, that's the only reason it can work. I think that's the only reason. Otherwise, as I mentioned, the syntax works correct. I mean, there's nothing wrong with the syntax. So the last and the easy one. Show the maximum, minimum, and average shipping cost for orders made by customers from California. Let's don't spend time on it and just see the result, the syntax, because we want to go for the assignments. So select maximum of the shipping attributes from the sale table as maximum of the shipping and also the minimum and also the average. So technically we have three function, and then from the sale table, we are joining the customer table through the customer ID where the state is California. So how many attributes we are going to have in the output? 3. How many rows we are going to have in the output? How many rows exactly we are going to have in the output? 1. Just the maximum for the California, minimum for the California, and the average for the California. Okay, so let's go to the assignments. The last assignment of this chapter, which is gonna be in 6.9 section, the assignment 6.8. The same table. This last part is related to the left, right, and left, right outer join. So we had it on 2 weeks ago. So just let's do some assignments for this. Before watching the answer again, to read the questions and try to understand it. And again, all of these are going to be recorded for you. List products, product ID and product name, whose list price is greater than 100, and how many sales, count sale ID in the sale item there are for each product. So technically the first line exactly telling us about the select statement. So the product name, product ID from the product table, and counting the sale ID as a number of sale. From which table? Product table. We are joining to the sale table. But the point is, also include those that have not been sold. Also include those that have not been sold, which means using the left function. So give me the X area, the Y area. The X area, the customers that have not purchased. Y area, those that purchased. Again, just pay attention to here. They are all recorded for you. You can watch them later. Sort the output data by the number of sale items. Name the column number of sales. So simple. Just a normal join function. This time you just need to pay attention to the left function. Left outer join again. I don't remember that I mentioned it a couple of sessions ago or not. It doesn't matter. We can mention left join or left outer join. Outer is optional, so there is nothing big deal about it. So you can just have it. Sometimes people would just mention it. Sometimes it doesn't matter. Left outer join, left join is the same. Sale item from product to sale item table, which attributes product ID, where the list price is over 100. We have the aggregate function, which is the count. So technically, we have to use group by for those attributes: product name, product ID, order by, number of sales. Okay. So technically, in the output, you're gonna have 7 record. The next one, list all manufacturer ID, name, and number of purchases made from that manufacturer. So the number of, which means counting the purchase ID from the product table as a number of purchases. Include manufacturers where no purchase have been made. So again, just because of this specific condition that those manufacturers that we haven't made any purchase from them, so we have to use again the left function. Purchasing. So the output data by the number of purchases, name the column number of purchases. So technically similar to the previous question. So in that case, we have no extra condition for it, selecting whatever. The only thing that matters here is using the count function as an aggregate function from manufacturer table, joining the purchase table. One more time. This table, this table. The first table here is manufacturer table. The second table is product, purchase table, sorry, purchase table. I was telling product, purchase table. So when we are doing the normal join, we are just dealing with this common area, which is the manufacturers that some customers purchased something from them. But when we are saying manufacturers where no purchase from have been made, which means this area. In order to calculate this area plus this area, we have to use the left join. Clear? Any question?
Why did you actually
First of all, because we have both here, manufacturer and manufacturer name here. So we have to. If I remove the manufacturer ID here, I have to also remove whatever attributes, 1 to 100 attributes we have in the selected statement next to the aggregate function, we have to mention all of them in the group by statement. It doesn't matter how many. In the last example, before the last assignment, before the exam 2, how many times there is a typo here, how many times has each product in the flats category been purchased? How many times, which means counting. We have to use the count function. Include those items have never been purchased as well. So again, this is a code, have never been purchased. Again, we need to add something here, which means again, left function, left join. Show product name, product ID, sort the data, whatever, it doesn't matter. Select product name, product ID from the product table, counting purchase ID, okay, from the purchase item table, and name it as a number of purchases from product table, left outer join or left join to the purchase item table. And what is the common key between these two? Are product ID. Now it is the time that we need to use the where instead of having, because we are mentioning about some condition as a general. So we are just dealing with the one specific category, which is the flats. Group by product name, product ID. Why these two? Because these two are available next to the aggregate function. We have to group them by those. And the last one, simple order by number of purchases. So, any question? Is the code logic clear? Yes. So, first of all, let me stop the Zoom.